Hi, I'm here to introduce you a paper Squeeze-and-Excitation networks, which is a famous paper about channel attention for CNN baselines. In the convolutional neural networks, the relationships between channels are expressed as the weighted sum of spatial local information of channels. This makes the channel-wise relationships to be limited with local information and makes the relationship implicit, which makes it hard to understand. To generate an explicit channel relationship using global spatial features, the authors introduced a lightweight module called an Squeeze-and-Excitation block, or an SE block, which is consisted of a squeeze step and an excitation step. The squeeze step aggregates the spatial information of each channel through a simple global average pooling. In practice, more sophisticated operators can be used. However, global average pooling is still effective. Then the excitation step captures a non-mutual exclusive channel relationships using two fully connected layers around the ReLU function and with the sigmoid function at the end. A non-mutual exclusive relationship refers to allowing multiple channels to be emphasized while avoiding most of the channels being deprecated, like a one-hot activation. Also, we can see that the fully connected layers reduces and expands the channel dimension for better generalization and to reduce the computation overhead. The output of the SE block is also called the self-attentions of channels, or a channel attention. The channel attention will finally be multiplied channel-wise to the original input. These SE blocks can be integrated into Bayesian networks such as InceptionNet, ResNet, and to more complex state-of-the-art networks such as ResNext and MobileNet. And further, note that these SE blocks comes after every Bayesian module of the baselines. The authors showed that the SE blocks enhances various CNN baselines with various training settings and tasks while being cost efficient. For image classification and ImageNet datasets, the results shows that integrating the SE blocks significantly decreases the errors for all baselines tested. The SE block still enhances the baselines trained on different datasets such as CFAR and with training techniques such as shake and cutouts. SE blocks even benefits baselines for different vision tasks such as place recognition and object detection. This reflects that the SE blocks are well generalized. The authors also show that integrating SE blocks increases the parameters and computation overhead with a very small margin, which means that the SE block is a lightweight, cost-efficient module. Using the explicit nature of channel attention, the authors provide the plots of channel attentions to show how they work on various depths of the network. Each color lines refer to the channel attention generated when passing images of each classes. The attentions of earlier layers show similar patterns across classes, which means that they help to extract general low-level features from the input. However, we can see that the attentions of deeper layers are different across classes, which means that they help to extract class-specific high-level features. On the other hand, the attentions at last stages are less important since they are either saturated or simply scaled. The saturated attentions are similar to the identity operator, so they are negligible. The attentions with different scales can be rescaled by the classifiers at the end of the networks, making these attentions less useful. So the SE blocks responsible for these attentions can be removed, resulting to making lighter networks. Lastly, by integrating SE blocks to a deep ResNext baseline, the authors won the classification competition of 2017. In conclusion, the SE block is a lightweight module that can benefit most CNN baselines by introducing an explicit channel attention using global spatial features. These are researches about more efficient channel attention modules with various approaches for those who are interested. I wish my presentation was helpful, and I wish you good luck with other presentations and quizzes. Thank you.